Hello everyone. Welcome to Makaut Smasher, your ultimate guide for BTech, CSE and IT topics. In this video, we will be taking a comprehensive overview of the subject computer organization for the second year, third semester, and an essential cornerstone for understanding how computer work internally. So whether you are curious about how instructions are processed and how memory is managed or how the data flows in a system, this subject forms the backbone of the computer science. We will give you a glimpse into the key areas like the computer arithmetic, the instruction set, memory organization, and much more. So, if you are a second year Makaut student or just someone to eager to learn, this video is for you. Stay tuned for a quick yet detailed journey into the fascinating world of the computer organization. So, let's get started. So, at first, introduction. Computer organization explains the fundamental structure and operation of a computer system. At its core lies the stored program concept, where both the instruction and the data are stored in the memory. The execution of a program involves fetching the instruction, decoding them, and executing them in a sequence. Registers, ALU, memory, and control units form the building blocks of this architecture. Operating system and compilers facilitate the smooth translation and execution of high-level code into the machine executable instruction. This chapter provides the foundation for understanding how every component in a computer collaborates to execute the task. It's where theory meets the practice, laying the groundwork for advanced exploration into the computer architecture. So, now computer arithmetic. Arithmetic operations are central to the computer system, with binary representation forming their foundation. The chapter begins with number systems and transitions into the fixed and floating representation. Topics like the overflow and underflow demonstrate the challenges in representing the real world numbers in the limited bit widths. Techniques for designing the adders, such as ripple carry and carry look ahead, enable the efficient computation. Booth's algorithm for multiplication and restoring and non restoring methods for division showcase the brilliance of algorithmic design. Floating point arithmetic based on IEEE 7554 standard. It provides a universal way to handle the decimal numbers. Mastering this concept ensures an understanding of how computation drive all the computer processes. So now the instruction set. The instruction set is the language a computer understands, defining the operation it can perform. It includes the instruction formats, the addressing modes, and the sets of commands for various tasks. Addressing modes determine how operands are accessed, like the immediate, direct, indirect, indexed, various type of operands or addressing modes. The fetch, decode, execute cycle is powered by the instruction, with each format specifying the operator codes and the operand references. A well-designed instruction set enables the efficient programming and execution, balancing the simplicity and the functionality. Understanding the instruction set is critical to optimizing the program execution and forms a bridge between the software and the hardware in the computer system. So now the memory organization. Memory is the heart of the data storage and the retrieval in the computer system. This chapter delves into the memory unit design, exploring the static and the dynamic memory. Memory hierarchy from the register to the cache and main memory to the secondary storage ensure the efficient data access. Associative memory introduces the content addressable storage, while the cache memory boosts the processing speed by storing frequently accessed data. Virtual memory extends the physical memory through the disk storage, enabling the multitasking and the larger program execution. CPU memory interfacing forms the core of the communication, and the data path design ensures the seamless read-write operation. Memory organization is pivotal for achieving the optimal system performance. So now the control unit. The control unit orchestrates all operations within a computer system. It translates the instruction into control signal for other components. Hardware control uses the combinational circuit for fixed logic, while microprogram control employs the microinstruction stored in the control memory. Instruction pipelining enhances the performance by overlapping the instruction execution stage, akin to an assembly line. Efficient control unit design ensures smooth coordination among the CPU, memory, and the I/O system. This chapter highlights the importance of the control flow and the evolution of techniques for maximizing the system efficiency. So now the bus structure. So the bus structure is the communication backbone of a computer system. It facilitates the data transfer between the CPU, memory, and the peripheral devices. A system bus typically consists of address, data, and the control buses. Handshaking protocols ensure the synchronization between the devices, preventing the data loss or corruption. The efficient design of bus architecture is critical for high speed communication and the system's stability. This chapter lays the foundation for understanding the how the data flows within a computer, setting the stage for advanced topics like the interconnects in the multiprocessor system. So now the input output organization. The I/O operation connect the computer system to the external world, enabling the interaction with the peripheral devices. Handshaking mechanism ensures smooth communication between the devices with varying speed. Port I/O, interrupt-driven I/O, direct memory access (DMA) are the primary methods for data transfer. While port I/O is simple, interrupt-driven I/O reduces the CPU overhead. DMA allows the data transfer directly between the memory and the devices without the CPU intervention. Efficient I/O organization ensures the better system performance and the seamless device integration. So that's all for this brief overview of computer organization. We have covered the core topics, giving you a glimpse into how computer process the data, manage the memory, and communicate with peripherals. This subject is crucial for building a strong foundation in the computer science. In the upcoming videos, we will dive deeper into each chapter, exploring the concept with detailed explanation and examples. Make sure to subscribe Makaut's Measure for more insightful content. Don't forget to like, share, and comment if you found this video helpful. Until next time, keep learning and smashing your goals.